Hey, good afternoon. It is Tuesday, April 28th, 2020. And so we're wrapping up the semester. So this week we're going to talk about receivers and a little bit of the news and everything else that is going on in the world. So hopefully everybody is doing okay. Like I said, this is the day before the official end of the semester or the classroom portion of it. So uh, the face to face, but we don't do face to face. So hopefully everybody is doing well, and you are all set for the summer. So if not, you make sure you get a hold of me if you're still trying to figure out classes for summer or fall. Get a hold of your advisor. If you're in UAS, that is James Wicks, and he will be able to help you. So real quick, Quiz 5 opened on Monday and it closes Saturday night at 11:59 p.m. So this is the fifth and final quiz for the class. There is no final. So pretty much it's just a 1 credit hour class. Was to familiarize you with the lab, some of our procedures, some of our equipment. And I know it's kind of difficult to do this remote delivery, but this is so that we don't have to cover everything in 3710 and the lab 3711 unmanned aircraft in that, so we can focus on building and flying. So once again, make sure that you get the quiz 5. It's open. There's plenty of time to do it, so it's been open for a total of be open for a total of 6 days. So make sure that you get it done. The other thing is tomorrow, April 29th, is the pass-fail option. You have to make your decision by 11:59 p.m. So just a reminder that the pass portion of that is any grade from a D- to a B+, you will get a pass for the course, and no grade, just a pass, so it won't affect your GPA. But anything less than a D- will still count as a failure. So consider accordingly. So right now, all the grades are up to date. So if you go into your course and select grades and go into assessment, assess grades, you ought to see your running total on what you have as of today. Okay, so you get started. So this shouldn't take a whole lot of time, but I just want to go back and revisit. So on transmitters, and so we're talking about receivers today, but on transmitters, there is an analog signal, which is the PWM, okay, which is a pulse width modulation. And you notice that it basically sends a signal from the transmitter to the receiver based on the width of the pulse. So different widths mean different things. Same thing is the other transmitter we can have is a PPM, which is a pulse position monitor. And notice the difference. It's where that pulse is always the same width, but where it appears within that time cycle determines what action it's commanding uh, the servos or the throttle or whatever other equipment in there, what it's doing. So a little bit different on PWM, okay? So pulse width modulation and PPM. So getting to that, and I'm going to go back into touch base. So we primarily use the TGY, the Turnigy i6S. It's a low-cost transmitter. It used to be before the embargo, you could pick these up for about $50. I don't know now that we've got or I won't call it the embargo, but the tariffs. Now the tariffs are on, I don't know how much they cost. But for us, it's a really good transmitter in there. And the other thing I want to bring is, so it's a 6-channel. So we can either do, so this is one of the ones that can either do PWM or PPM. So we'll actually go in and designate. So some of our builds will use the PWM feature, and some other builds where I talked about before, S buses, we'll use the PPM, and we can configure this for either or. We can't do both. Now, one thing I want to bring up is on transmitters, sometimes you'll hear the abbreviation for that is TX. Okay, so TX would stand for a transmitter. And if you look down in the lower right-hand corner where it says receiver, receivers are known as RX. So sometimes you'll see something that's a TXRX, which means transmitter receiver. Sometimes you'll see that these are separate. So I just want to let you know if you see either one of those abbreviations, that's what it stands for. Now, the other thing is, so all of our, and I'm gonna go back up to this picture because we've got both a PWM and a PPM receiver in there. Like we mentioned before, all transmitters transmit on 2.4 gigahertz. So there are some times when we'll have 4 transmitters transmitting at one time. So how does each transmitter, okay, know how to control its aircraft? So, in the old days when everybody was on the same frequency, it was possible for somebody else to control your aircraft, right? And now with electronics that we have in there is we actually pair up, and you guys are used to Bluetooth and everything, similar to that, where you have to actually pair the devices together. And we're going to do the same thing with the transmitter and receivers. So in this case, what they pairing is what we call binding. So we're going to bind a receiver to a transmitter. And that's how we can operate, have all the same transmitters on 2.4 gigahertz. We can have 4 or more airborne at the same time, and we won't have any interference for that. Now, there's some different procedures for PWMs and PPMs, and it's brand specific. So this brand right here, and I'm not even sure who this one is, I just found it, but here's a receiver. Notice it doesn't have all the fancy case. A lot of times you can pick these up relatively inexpensive, and they're great receivers. But in the upper right-hand corner, you'll notice what they have is called a bind plug. Now, for a bind plug, works with PWM receivers. So you can look down and see all the different, I guess teeth, for lack of a better term, all this. But here is to bind this receiver to a transmitter. We'll follow whatever procedure the transmitter has. And some of them are a little bit different on how you do that. So we'll look that up. And what we'll do is you take this bind plug and put it in either the left or the right far side. Now, if you notice, all this bind plug has is a wire in a loop. There's nothing in the center. So when you insert the bind plug into the binding port, and they're labeled differently, but you find what it is, what that does, it shunts out that port, and it tells the receiver to go into a binding mode. So in this case, we would turn on the transmitter. We would, if we have to select it, we may have to hit a button, we may have to go into a menu and select it. We tell it to bind. We put the bind plug in the binding port, and then we power up the receiver. And prior to this, before the receiver, when the receiver is powered and it's not bound, so we haven't bound it to a transmitter yet, you'll see a flashing red light, okay? Typically there'll be a flashing red light. And on this one right up here, it kind of looks like there's an LED right there. So we would see a flashing red light. When the receiver is bound, so in other words, the transmitter and the receiver do their handshake and they're bound to each other. So we bind, put them in the binding mode, that light will go solid red, okay? So that we know it is bound to that receiver. Now, very important is when you're done, is what you do is you depower the receiver and make sure that you pull this bind plug out. Now, the interesting thing about bind plugs is every time you get a PWM receiver, you got them. So you'll have hundreds of these things laying around. We do, except when you really need it. And then you can't find it. Typically what we do with this little loop is we'll put it on the handle and kind of loop it through and secure it so if we ever need it in the future. Now, the next time that I power this receiver on and my transmitter, remember it's always important to turn on your transmitter first, so it always has a signal out there. So turn on your transmitter. When I power up this receiver, okay, the bind plug is out, okay, then I will see a solid red light, which means that they are talking to each other. Okay. Now on the Turnigy i6S, we have a little battery indicator for the receiver. So if we have a good connection, we'll actually see that. So that is another kind of check that we do to make sure that they are talking. If you inadvertently leave this bind plug in, what you've done is left the receiver in the binding mode. So if you try to go fly right away, none of your signals would get through, and it could cause problems. All right, so that's how typically we do a PWM, is we have to use a bind plug in order to bind them. Okay. Now, there's different, like I said, different receivers, and what you can see in the upper left, this is one of the ones that you'll use. One of the first ones that you'll use is the Turnigy for the i6S is a PWM receiver, and you'll notice that on the bottom it has a bunch of 3 rows of pins that we will go ahead, and since it's analog, we will put servo extensions, basically wires with 3 connectors in there. We'll plug those in, and we will run those to the appropriate either servos, or we will run them to the flight controller. So we talked about CC3D boards and some of the other ones. On the right side up there is, this is a PPM receiver, so it's also for the i6S, so it's a Turnigy. But notice it only's got 4 pins. It doesn't have the entire rows of pins in there. So a little bit different on this one is PPM can also be what they, if you notice up there, it can be a S bus. And I talked about it last week in an S. So on an analog receiver on the left, it can only control 1 channel at a time. So this looks like it can handle 10 channels. So that says 10 channel receiver. So we can actually have 10 channels. If I'm going to use all 10 channels, I need to run 10 separate wires from here out to my servos or what other equipment that I'm going to use. On the right, the PPM, since it has an S bus, is I just need to put 3 pins. Okay, so I just need the S bus, the VCC, okay, V stands for voltage, so that's my power, and then G and D stands for the ground. So with those 3 pins, is I can get up to 10 channels on an S bus. So that's the difference between an analog and a digital. Okay. Now, the other thing for this you'll find out is on the analog, we have to use a bind plug. On the PPM is when we go through our procedure with the Turnigy i6S, what you'll find out is we go into the menu section of the Turnigy, we go to bind, and unlike the analog where we had to use a binding plug, is when you power up this receiver, it will automatically seek a transmitter. Okay, so there is no binding plug for that. So you'll see a flashing red light, which means it hasn't bound yet. And then when it has bound, it will go solid red. And that's another one of our tests that we can do when we power up to make sure that the aircraft, the transmitter is talking to the receiver. If we look at the receiver, we should see a solid red light. If it's blinking, it's not bound. Now, one of the downsides of this, on both of them, we've got to be careful since we're going to be having 4 groups in there binding around the same time, is you only want to do one at a time, because if you put your transmitter into binding mode and somebody else is already powered up, it's going to automatically bind to that aircraft. Now, one of the things that you can only bind to 1 receiver. So whoever was bound to that before, is theirs is going to drop off, and now you're going to control that aircraft. Now, we've had it happen. So we've had opposite corners, and students had control of the other aircraft. So you got to be careful when you do these, that you only do 1 at a time. And then last, sometimes depending on the sophistication of the receivers, is they could either do PWM or PPM, so depending on how they configured. So if you see this radio link that down there, the RAEF, so if I'm using the PWM, okay, so the pulse width modulation, you can see there it goes channels 1 through 8. But if my transmitter can handle it and I can do an S bus, then if you look down on channel 1, it says S bus to the left. So we can actually run instead of having 8 sets of wires coming out of this, we can only have, or we only really need one wire um, going into, in this case, it'd be our flight controller. Okay. So some can do both. Now, some, especially when you get into Spectrum, so these are the high end, but you can also get telemetry modules. So typically in the early days, what we'll do is we will send a signal from our transmitter to the receiver. The aircraft will do something, and since we're in line of sight, we will be able to make corrections. But sometimes we'll need telemetry coming back if our transmitter can handle it. So in this case, we can send signals to this receiver, but this receiver in that separate modules with the 2 little antennas that are sticking straight out has the ability to take telemetry and send them back to the transmitter. So if I had some type of LED screen in there on my transmitter, is I might be able to get altitude, airspeed, heading, voltage, satellite signals. So there's a bunch of data. Not only can we send from our transmitter to the receiver, but the receiver can also send back to us. So typically you find these in the higher end systems. Okay. Now the other thing is when you are attaching a receiver to either servos or into a flight control module, you've got to be very careful on how you connect the wires. So in this case, I showed you on our PWM for the Turnigy, is it has up there a circle S, a circle plus, and a circle minus. So if I was that, and this is a bad picture, but there's actually 3 rows of pins in there, is the top row will be the signal wire. Okay, so yeah, the S stands for signal wire. And then the middle wire is the positive, and the bottom row is the negative. So you don't want to get these reversed because there's a chance that you could burn out your servos or actually damage your transmitter. So be very careful when you wire these up. Okay. Now, here's some of the possible wires. And I'm going to go back to this to bring it up real quick. Now, if you remember that I said that receivers are powered by 5 volts, okay? And you can see on this one right here, it says its power is acceptable from 4.0 to 6.5 volts DC. Now, that power will come off either a ESC, okay, electronic speed control, that has a BEC, a battery eliminator circuit. And if you remember, BECs, their only purpose is to take that battery voltage and make sure that they drop it down to, around 5 volts. Okay. Okay. Or if this is being powered off what they call a power distribution board, sometimes that power distribution board will automatically have a BEC built in and it will step it down. But if you put more than 5 volts, so in this case, if you put anything less than 4 volts on it, this may not work. If you put anything more than 6.5 volts DC, it may burn it out. So typically we get off our BEC, okay, battery eliminator circuit, is we get that 5 volts. Now, in the case of an aircraft, okay, or anything that has servos, is these 3 rows of pins, or the column in this case. So if I'm using channel 1 through 10, when I plug that in, is that servo, or whatever equipment that is going to, is getting its power from the receiver. So once again, servos run at 5 volts DC. Receivers run at 5 volts DC. So when I make an input, that power that's going to that servo is coming, or it could be a switch to turn on a camera or something, okay, comes from, okay, this receiver through the battery eliminator circuit. Okay. Now, a lot of times you'll see we'll use servo extensions is what they're called. They come in all kinds of varieties. The upper left, it looks like a brown, an orange, a red, and a yellow. There's another one that's an orange, red, yellow, and the one down on the bottom is black, red, and white. So sometimes you've got to figure out, excuse me, which is the signal wire, or making sure that whatever wire that you typically put on the signal pin, okay, is consistent when it goes to the servo or the equipment. Now, in the case of the upper left, is typically, in this case, it's not red, red, black, which would be power, negative, and, the signal wire. In this case, brown would be our ground. That red or orangish looking color would be our power, and the yellow would be our signal. So same thing with the one down there in the middle. Brown would be negative, would be the minus, the red the positive, and in this case, the orange would be the signal wire. Now, some of the servo extensions and some of the receivers, especially Futaba, which is a very respected brand name, a high end, very hard to see down in here, but it has, right down in here, really hard to see, but it has that little groove in it, or basically a keyway that will slide in, so everything is always correct. So in this case, neutral is the black wire, the positive is the red wire, and the signal wire would be white. So a lot of times if you don't get any power to your equipment, you need to check to make sure that you've got everything hooked up right. Okay, so here's like I said, here's a good example of a servo. So if we were going to plug this one in, and so if we were going to plug this one in, there's a servo in the background. In this case, the ground would be brown, the power is red, and the signal wire is yellow. And if I come over here, then I want to make sure that my signal wire is on the top row of pins. And so I would turn this to make sure that that yellow wire is turned. So when I plugged it in, it makes contact with that top row. So that's one thing that's very important when you're hooking up your equipment, is to make sure that you've got the right ones in the right position. Okay, the other thing is I want to talk about real quick, a lot of times, so in turnigies, so in this case, we're going to use the PPM and the PWM receivers, so they will work fine with each other. But in most cases, we cannot take another brand of receivers and make them work. So in other words, with our transmitters or Turnigy i6Ss, I can't bring in a Spectrum and I can't bring in a Futaba. So normally, is because of proprietary, the way the software and hardware that they have in there, is we just can't take any receiver and expect it to work within the Turnigy. Now, with that being said, is we just got one of these. So this is a Jumper T16. These are running about, I think I paid $160. So we're going to evaluate this, but this is what they call an open source transmitter. So what the difference is, there is open source means it's community based. People can add to this. They can access the programming to this, the codes and everything. And there are people out there that are cracking the codes on these other receivers. So it is possible with this jumper to actually, in this case, we may get it to work with a Turnigy, we may get it to work with a Spectrum, but nobody's cracked the code on the Futaba yet. For that. So they're, like I said, they are, it's an open source, so there's a lot of things that you can do with this. The other thing you'll notice that down here, it's got an LED screen. So if your receiver also has the ability to transmit telemetry, you can actually get that information back on your transmitter. So, so we've got a little HUD there that, an attitude indicator. So right now the aircraft's in a right bank. We can see on the upper right is our battery voltage in there. We're at 47, about 47%, and it's got flight time, it's got direction, it's got vertical speed, and there's a whole bunch of information. So we are looking at these two later on, is going over to these as a kind of the next step up. So the Turnities do a great job for us. We're really happy with them, but this gives us a little bit more flexibility to program some of our aircraft and then be able to share one transmitter across a variety of different aircraft. One thing is, if you have a DJI product, this will not work for DJI because DJI, once again, is proprietary. Nobody's broken the code. But other brands, this may work. So kind of thinking about this is, if it works with different receivers, it can actually reduce your costs quite a bit. So you can have a variety of different equipment. Okay, that's all I have. I'm going to record this and I will post it for those who are interested in watching. So anyway, thanks for a great class. I know we ended unusual. So we went from a classroom to remote delivery, and the good news is, so Thursday in Tennessee, it is not, the stay-at-home order has not been renewed. So I've already seen that businesses are open. So hopefully we can get back to normal for that. So it's kind of strange being on a campus with no students. But hopefully when we start back up in fall, everything's resolved and we can get back to whatever the new normal is. So I think we're going to inch into this. So should be good. But thanks for a great class. And I hope everybody has a safe summer, and we'll see you back during the fall semester.